Yes, my dear friends, tutorial 21, and in the series of distance protection of transmission lines, it is ninth video tutorial. We have been talking about the problems in distance measurement. We have talked about many problems. Now we are coming to one more problem, that transmission line is fed from both ends. If transmission line is fed from both ends, then what will be the problem that we would like to see? I would want to talk with reference to figure only. I've got two generators, GA and GB. Transmission line is AB. On one side it is fed by generator A and another side generator B. Generator A has got the induced EMF EA, and generator B has got induced EMF EB. Madhuri, બોલીને કેતો છે બૂમ મારે. બહુ અવાજ કરે છે. Now GA and GB both are feeding the line. On A some loads are there, on bus B some loads are there, that is okay. But you see, it is also quite possible that both the generators may be of different kinds. One generator is thermal power plant, another generator is hydropower plant. So you see, their current voltage relationships are different. Their vector relationships are different. And when this happens, what happens is this. Say, if I take an equivalent circuit, it is something like this. EA, then ZA, that is the impedance of generator A, EB, and ZB is the impedance, internal impedance of generator B. At F, the fault occurs. So ZAF is the impedance from generator A to fault F, and similarly ZBF is the impedance from generator B to fault F. But as we have already talked about, when fault occurs, the fault resistance is involved. So fault current IF, IA plus IB, that is IF, is passing through RF. Now that troubles us. That is a culprit. So if we talk further, it is something like this, that IA and IB are not in phase. As I told you, see, both generators are of different kinds. Therefore, vector relationship IA and IB may not be in phase. So IA is leading IF. Say, for example, IA is leading IF by angle alpha and IB is lagging IF, the fault current, by angle beta. And IA plus IB obviously is IF. So this is the vector condition. Now my problem is this, that I've got a Moore relay. So Moore relay current vector is I, but I means IA. Current at bus A, current at generator A, IA is my reference vector. Fault occurs at F1. F1 means outside the Moore circle. Fault occurs at F1. So actually the relay should not operate. That means if it is a third zone, relay should not operate in third zone. If it's a second zone, it should not operate in second zone. If it's a first zone, whatever, relay should not operate in its given zone for fault at F1. But what happens? To AF1, that is the impedance from A to F1, the fault impedance is added. which is IF-RF. And unfortunately, IF is not in phase with IA. It is lagging by angle alpha, as we have already discussed. I will show you. IA. That means IF is lagging IA. IA is leading IF, means IF is lagging IA. So IF is like this. It is lagging IA by alpha. So IF into RF, that takes me to P, point P. Point P is within the characteristic, so relay should not have operated and it operates. That means the impedance measured should have been AF. Instead it is AP. That is, impedance measured is less than what it is. Impedance measured is less than what it is. It means overreaching. At point A, that is relay RA overreaches. It should not have operated and it operates. It should have operated. It should not have operated and it operates in third zone. It should have operated in third zone and it operates in second zone. Something like that. You get my point. It is overreaching. Overreaching occurs for the zones when this line is fed from both ends and when there is a vector relation IA and IB are not in phase. This happens. At end B, what happens? At end B, reverse thing happens. F2 and IFRF. You see, I reference vector is IB and IB IF is leading IB by angle beta. That means my impedance measured is BQ. It should have been BF2. That means relay should have operated and it does not operate. That means it underreaches. Right? It should not operate. I mean, sorry, it should operate. It should operate. BF2 means it should operate, but it does not operate. So impedance measured is less than, impedance measured is BO is more than BF2. So here it is overreaching. It should have operated. It should have operated, but it does not operate. It means underreaching. So that there is a mistake. There is a, I should say, there is a typographical mistake. I'll read again. At A, at A, at A, it is written it is overreaching. It is not overreaching. It is underreaching. Right? Because it should not have operated and it operates. If the relay should not operate and it operates, that is underreaching. Relay should not operate. That means the fault is outside, but it is seen inside. That is overreaching. This is correct. This is overreaching. But this is underreaching. So here it is a typographical mistake. It is underreaching at relay B. Relay B underreaches. It should operate and it does not operate. F2 is within the circle, but the point seen is at Q. So it is underreaching. This is known as underreaching. Relay should operate and it does not operate. It is underreaching. Here, this thing, relay should have not operated, but it operates. So it is overreaching. So this overreaching and underreaching effect occurs for when line is fed from both the ends. So what is the solution? The solution is don't use mho characteristic, don't use reactance characteristic, but use ohm characteristic. Say F2Q, that line is ohm characteristic. For NB and for and sorry, and for NA you use F1P, that line. That is ohm characteristic. So use two different ohm characteristic. That is the solution for such a problem. Right. So that is the line fed from two ends. So distance relay finds trouble there. The another trouble is double circuit line. You see, most of the lines are double circuit line. Double circuit line means parallel feeders. Most of the lines are parallel feeders. I want to send power from Ahmedabad to Baroda. If I send power by single line, I can send 100 megawatt. If I use double line, second line, then I can pass 200 megawatt from Ahmedabad to Baroda. I can send double the power. Extra expenditure is that of conductor and insulator, not of tower. Tower is already there. So parallel lines are very common. My problem as far as distance protection is concerned is this, that we say that the relay measures impedance from relaying point to fault point. But we are telling that self-impedance, self-reactance, self-inductance, right? That is what we are considering. Z is R plus Jx. What is X? That X is due to the current flowing in that particular line. Say that there are two lines, line A and line B. Because of line A, X is there and that it measures. But line B is also there. In line B is also current is passing and that current creates flux and that flux cuts line A, another line. So there is a mutual reactance in second line. In line A, there is a mutual reactance due to line B. So that mutual reactance is added to self-reactance. So relay measures more impedance than what actually it should measure. And when it measures more impedance, it is underreaching. Relay underreaches, right? When it reaches more reactance. Now you see, as far as this mutual reactance is concerned, this mutual reactance effect can be cancelled if three lines are there and they are transposed. We are saying no, that they are transposed. RYB are transposed. After certain, say after 50 kilometer or after 25 kilometer, uh, line A is line A is uh, line A is transposed, right? Uh, that means Y takes place of R takes place of Y takes place of B takes place of R. So positive sequence impedance and negative sequence impedance are nullified. That does not create problem. But zero sequence impedance cannot be. So zero sequence mutual reactance creates a problem. And therefore the distance relay underreaches. Solution to this problem I am not touching because solution to this problem is a research problem. Dr. Bhavesh Balja, who is a student of Birla Vishwakarma Mahavidyalaya, he passed under me only. I was his teacher. He passed in 1999 B. Then he did his master's, right? And then further he did his PhD at IIT Roorkee, and now right now he is associate professor or probably professor at IIT Roorkee. He has done research over this and he has suggested a solution to this problem, double circuit line. Solutions are complex, therefore research problems I don't touch. Problem is there that I am showing. Solution, I am not showing. Similarly, TID line, similar problem. Solution, I mean problem I will tell. Solution I will not tell. What is TID line? TID line is this. Very rare, no? TID line. Some 220 kV line from A to B is passing. In between there will be T. So 220 or 132 kV line, T is very rare. But I was also finding that it may not be there anywhere. But then Professor Bhavesh Bhalja himself told me that near Bharuch this T is there. 220 kV line T is there. Now, what is my problem? My problem is this. Sir, there is relay R1, R2, R3, R4, R5, right? Now, relay R1 has to measure the distance from relay to fault F1. It has to measure relay to fault F1. So, it has to measure impedance AF1. But what does it do? It has got a current use. It has got an information of current, but it does not have information of voltage, because what is voltage? Voltage is I1 into ZAT plus I1 plus I2 ZTF1. That is the problem, right? That is the problem. See, my problem is this I1 into ZAB plus I1 plus I2 ZBF upon I1. Current is I1. So, what does it read? It reads ZAB plus ZBF plus I2 by I1 ZBF. So, it should have measured ZAB plus ZBF only. That is the right impedance. But some extra impedance it measures. So, once again it under reaches. Solution to this problem is that of the research world. So, I would not touch it. But this is a problem. This is a problem. By explaining to you so many problems, I am trying to tell to you that distance relay is also not a final solution to the protection of transmission line. Final solution is only differential protection or line differential protection, about which we are going to talk. You see, more than TID line, this is more common. More than TID line, this is more common. There is line AB. Fault occurs at F. But at B, some another generator C also is feeding fault. So, relay R should measure impedance AF. But it does not measure AF. It measures I1. Right? What is the voltage that voltage is available? I1 into ZAB plus I1 plus I2 ZBF. So that I2 component is troubling me. So once again, here also there is problem of underreaching. And such cases are very common in our power system. Right? So distance protection is going to give trouble when such cases are coming. So, so to say, the first problem today we discussed was line fed from both ends. The problem we found out that more relay can be used, but the double circuit line or parallel lines problem is in the field of research, and that is suggestion is suggested by Professor Bhavesh Bhalja, who is at IIT Roorkee. This solution is also suggested by Professor Bhavesh Bhalja, right? That TID line. How you can correct this? Correction can be made so that relay reads the right impedance. But we will not be going to the research area, because I do not consider myself to be a researcher. I consider myself a consultant. I can give my consultancy to industries. I am poor at research. And my friends, I have got some apprehension towards research also, because if 1,000 researches are made, probably hardly 2 are useful to industries. 998 researches are just for the sake of a tag. I am simply Bhuvanesh Oza. I can call myself Dr. Bhuvanesh Oza. I went for interview at some college after retirement at 62. After 40 years of my total service, I went to some institute. The interviewer who had to take my interview was not taking my interview, but he was rather, so to say, recommending me to a person who has to take the decision that if you take Professor Oza, the college will gain so many things. College, it will be very useful. Professor Oza will be a very useful asset to the institute. The director of the institute was also trying to convince, but a person who had to take the decision told that a person, Professor Bhuvanesh Oza, who has got 40 years of total experience, 30 years in teaching, 10 years industry, trained some 40 engineers in Dubai, a multinational company like ABB at Dubai, Emirates Global Aluminium. Oh, Mr. Oza, you are unfit because you are not PhD. So, I'm sorry, my dear friends, but I have got little apprehension towards. All right, very good. If you are PhD, I'm happy. I congratulate you. I appreciate you. But if your PhD is useful, if your suggestion that you give for any solution is used by some relay manufacturer and then problem is solved, then I think your PhD is more useful. Care. Anyway, I have diverted, I have digressed. Main thing is this is a problem of research, and with all apprehension, yet I congratulate Professor Bhavesh Palja that he has tried this difficult problem and suggested solution to this. He has tried to give yet to third difficult problem, traction protection. You see, so Professor Bhavesh Palja is very intelligent, quite intelligent person. So there are many people who are in PhD. They are giving many important suggestions and many important contributions to the world of education. But this is, I want to say that this is a research problem. That is the only thing I want to hint at, right? Deadlines. So with that, I would end today's talk on distance protection. I would end always with some sentence. So I'm ending today also with a sentence once again told by Swami Chinmayananji. I am little bent towards the spiritualism, and therefore I'm not only a technical person. I do meet saints. 4 saints have come to my house also. So my house has been made क्या बोल सकते हैं उसको, it is, I'm very fortunate, my house is very fortunate that 4 big saints, 4 enlightened persons have come to my house and have taken tea and have taken lunch or dinner. So such persons like Swami Chinmayananji, Swami Anubhavananji, Swami Brahmavedanji, you see. So he is saying that to be angry, if you are becoming angry, then you are is to revenge the fault of others or ourselves. Somebody is doing fault. Why you are angry? That person did like that. So it is his problem, not your problem. He should have become angry, or if something should have happened to him, why you are becoming angry? So to be angry is to revenge the faults of others on ourselves. And the other sentence is, in all adversities, कुछ भी खराब हो रहा है आपकी जीवन में, in all adversities, there is always in its depth, a treasure of spiritual blessings secretly hidden. This will also pass away. जो भी हो रहा है ठीक हो रहा है, जो भगवान का है, whatever is done by God is always very good. It is always correct thing. We think that whatever we are trying to do is correct. No, we may not like what God is trying to do, but after all, God is trying to do for our goodness only. Somebody was telling that a fellow, a very big director, was to go to that, how many, I don't know how many floors, some 100-floor building on which a plane crashed and building fell down, a very big incidents. So there he was to go for a very important discussion, and that discussion was to give him an order of some crores of rupees, 1,000 crores of rupees. But before going to discussion, he went to bath, and in bathroom he slipped, and there was fracture. So doctor denied, you don't go. He was very angry. Oh, 100 crores, 1,000 crores I am losing. But his life was saved because plane crashed, that building crashed. Many people died, but this fellow was saved. So what God is trying to do, any adversities, we think that it is adversity, but it is not adversity. It is for good of us. I am sorry, this video is heard by all people in world. So Gujarati is so small a language in whole of the world. But some people must be knowing Gujarati. So those who are not knowing Gujarati may ask their Gujarati friends. In our Gujarati we say same thing. Ma karete mangal. Ma means mother, Parvati. Shankar's wife, Mahadev Shankar's wife. Whatever she does is good. Ma kare te mangal. My dear friends, with that, remember adapt me. Don't forget adapt me. Thank you. And I think good night for India, because it is about 11:40. So good morning for USA, etc. But maybe good evening for Dubai, etc. But good night for India. Thank you, friends.